Welcome to class today. Today is going to be class number 15, and if you just take a look at our pacing schedule, you could see we're going to be talking about increasing and decreasing function values, as well as inflection points. For homework tonight, I'd like you to please complete the worksheet titled Homework, changing y values of a graph and identifying inflection points. Also, we'll be working on the classwork worksheet separately, so we'll get to that in a little bit. Next assessment coming up, just so we're all on the same page, looks like it's November 4th, and that'll just cover these graphing characteristics. Okay, so just as a friendly review, last time we were together, we were talking about a bunch of different things, actually. We were talking about simplifying radicals, and we talked about how you want to find the largest perfect root that goes into whatever the radicand is. So for example, for 75, the largest of these perfect roots that goes into 75 is 25. 25 goes into 75 three times, so 25 times 3 is 75. And the square root of 25 is 5, so we would write 5 root 3. That's how we simplify radicals. If you take a look at 32, now the largest root that goes into 32 is 16. So we could actually write the square root of 32 as the square root of 16 times 2. Square root of 16 is 4. But I believe in this example in class, I showed you that even if you didn't go with the largest perfect root, let's say if you went with 4 instead, you could just keep simplifying and you'd wind up with the same answer. After we got done talking about simplifying radicals, we got back to quadratics, and we started talking about axis of symmetry values as well as vertex values. So remember, in order to get the y-intercept for any graph, whether it's quadratic or just a regular line, you always put 0 in for x. So you can see that's what we did here. To get the x-intercepts, you put 0 in for y. Most of the time, the problems are going to factor. So you factor them, you set the factors equal to 0 and solve. But if the problem doesn't factor, meaning you can't find two numbers that multiply to be the first and the last, and also add up to be the middle, we always have a backup plan called the quadratic formula. So you can see here we got the same exact answer doing both of those. The axis of symmetry we could find by averaging the x values. Just take the two x values, add them up, divide by 2. The other way that we talked about doing this was using the quadratic formula version, where you take the opposite of b over 2a and you don't include the plus or minus square root. Many of you chose to use that second version, which is fine. Most people like that, but if you forget the formula, you could always average the x-intercepts as well. And then lastly, to find the vertex, what we did is we took the axis of symmetry, the x value, and we plugged in that x value for all the x's, and whatever that equaled would give us the y value. So whenever you want to find the y value of an equation, if you have the x, you plug x's in, and then it will tell you what the y value was. We also talked about domain and range. If you take a look at the graph, it looks like it goes left and right forever, so that's why we said that the domain was negative infinity to infinity. It looks like the lowest the graph goes is negative 4, and then it goes up for forever, so we call that positive infinity. And that was pretty much class. We did a few other examples like that. We got the y-intercept, the x-intercept, a couple different ways. The axis of symmetry, I did it the way most of you chose to do it, using the opposite of b over 2a. Vertex, remember, you find the axis of symmetry, you plug it in, and that was pretty much what we did the entire class. So we came up to the board, and you could see some of your beautiful penmanship. Appreciate everybody coming up to the board, working together, meeting new people. That's all a very important part of learning. It's not just what you get from me, it's what you can get from each other, which is why part of your grade is participation. So let's get to the new section today. We're going to go to class 15. And today we're going to be talking about increasing, decreasing, and points of inflection. So we're going to build off of what we did during the last time we were together. Okay. In order to get started, let's take a look at an example. So let's say we had the function y is equal to x squared minus 2x minus 15. Okay. And what I want to do is just very, very briefly, we'll go quickly through what we discovered during our last class. So if you want to get the y-intercept, you just put 0 in for all the x's. So y would equal 0 squared minus 2 times 0 minus 15, or the y value would be negative 15. That's the y-intercept. To get the x-intercept, you put 0 in for the y. We have a couple different ways to do this. We could either factor or use quadratic formula. But numbers that multiply to be negative 15 and add up to be negative 2 would be negative 5 and positive 3. So this problem does factor. It would factor to be x minus 5 and x plus 3. When we get the x-intercepts, remember y is equal to 0. So x would equal 5 and x would equal negative 3. Those are our x-intercepts. We also talked about finding the axis of symmetry. Popular way to do this is you take the opposite of b over 2a. You could also get this by averaging the x values, right? So 5 plus negative 3 is 2, divided by 2 is 1. But most people choose to use this formula. So the opposite of negative 2 divided by 2 times 1 gives you the same thing, x value of 1. And then lastly, to get the vertex, remember we take the axis of symmetry value and then we plug it in to come up with the y value. So if we do that, the x value is 1, so we have y is equal to 1 squared minus 2 times 1 minus 15. 1 minus 2 is negative 1, minus 15 is negative 16. Okay, so the vertex would be your axis of symmetry, comma, the y value. So let's tie this together and see what this graph would actually look like, and then I'm going to teach you some new vocabulary words. Okay, the y-intercept is negative 15. The vertex would be 1, negative 16. The x-intercepts would be 5 and negative 3. The axis of symmetry is 1. So we get this beautiful looking graph. It's quadratic, so it looks like a parabola. It looks like the domain of this graph would go left and right forever. And when we're talking about the range of this graph, the lowest the graph goes is negative 16, and it goes up forever. Okay. So that's all review. Something else I want you to recognize are the y values, right? Remember, this is your y-axis. These y values are positive. These y values are negative. Instead of saying y, we could also say f of x. We know that f of x and y mean the same thing. So one thing I could ask you is where are the zeros of this graph? Okay. Remember, zeros, x-intercepts, and roots all mean the same thing. And we already found those to be negative 3 and 5. Something else I can ask you is the open interval where f of x is greater than 0. What that's asking you is where are there positive y values? It looks like there are positive y values after 5. I mean, these are positive y values. They're above the x-axis. Those would be positive. And it looks like any y value less when x is less than -3. So let's go ahead and write that down. So we're going to say any x value less than -3 would be from -infinity to -3, union with 5 to infinity. I could also ask you for the open interval where f of x is negative. So where are we looking at negative y values? All right, so f of x and y, remember they are the same thing. And it looks like the graph over here, these are all negative y values. Those are points below the x-axis, right? So I mean, all of these are negative y values. So let's go ahead and record that. And those happen between -3 and 5. When we're talking about open interval, that just means we use parentheses. We don't use brackets for this kind of stuff. Okay. Next thing I wanted to talk about are what are called inflection points. Okay. Inflection points are where the graph changes from increasing to decreasing. So when we're talking about increasing, let's write it down over here. So let's say open intervals where the graph is increasing. What this means is where is the graph going up from left to right. We could also talk about open intervals where f of x is decreasing. What this means is where is the graph going down from left to right. And also the open intervals where the graph is constant. This just means where is the graph flat from left to right. Okay. So let's go back to our graph and let's figure this out. Okay. All right, so let me just put the graph back here. So if you were to trace this graph from left to right, it looks like the trajectory of the graph right here, we're going down, 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 right until about this point right there. Okay, that's where the graph is decreasing. So if we're going to go answer that question, where is the graph decreasing? That's different from where is the graph negative. We're just, where is the graph going down from left to right? It's going down from left to right from -infinity to the x value of 1. That was your axis of symmetry, right? Where is the graph increasing? Well, if you just keep tracing the graph, looks like the graph starts going up from 1 to infinity. So really we just have a lot of different vocabulary. This isn't crazy math or anything. It's increasing from 1 to infinity. And then where is the graph flat from left to right? It doesn't look like it's flat anywhere. So we would just say, nowhere. Okay. I did mention before something called an inflection point. An inflection point just means where the graph changes from increasing to decreasing. And if you go back to our graph, it looks like the red highlighting was where the graph was decreasing, green is where red was where it was decreasing, green is where it starts increasing. It looks like the vertex, 1, negative 16, would be where the graph changes. So the only point of inflection would be 1, negative 16. All right, and we should also make sure that we always circle our answers so that I know what our final answer is going to be. So we covered a lot of new vocabulary there. We talked about where the graph is positive or negative. We also talked about where the graph is increasing or decreasing, which means something different. And a point of inflection is where the graph changes from increasing to decreasing or vice versa. Let's try a couple more of these. What if I gave you a problem like this? And let's say it was f of x is equal to negative 2x minus 1 and 2x minus 9. Now this graph is already factored for you. You're welcome. You don't have to factor it yourself. So let's go ahead and find everything that we just did. First thing let's do is let's get the y-intercept. I'll go a little bit quicker for this because we already talked about we get the y-intercept by putting 0 in for x. Y and f of x are the same thing. So we're going to do negative 2 times 0 minus 1, 2 times 0 minus 9. And if we do this correctly, it looks like the y-intercept would be negative 9. In order to get the x-intercept, we put 0 in for y. Factor, quadratic formula, this is already factored. So we just have negative 2x minus 1 times 2x minus 9 is equal to 0. Set the factors equal to 0. 2x minus 1 is 0, so x is 1/2. 2x minus 9 is 0, so x is 9/2. 9/2 is the same thing as 4.5. To find our axis of symmetry, we could do the opposite of b over 2a, which would mean we just have to distribute everything here. If we multiplied this out, we'd get 4x squared minus 20x plus 9. Don't forget the negative is in front of that. So you could use your opposite of b over 2a. You just have to remember to distribute this. In my opinion, it might just be easier to average out the x values. So 1/2 plus 9/2 is 10/2, which is 5. 5 divided by 2 is 5 divided by 2, right? Which is the same thing as 2.5. So I'm going to start drawing this graph just so I have an idea what's happening. And we know the y-intercept is negative 9. I'll put that all the way down here. The x-intercepts were 1/2 and 9/2, which is 4.5. I'll put that over here. We just figured out the axis of symmetry was 2.5. So if this is 1, 2, 3, 4, 2.5 would be right here. So I'm going to draw the axis of symmetry that goes through this point. Right? And again, the equation of this line is just x is equal to 5/2 or 2.5. We should also get the axis of symmetry, which will lead to the vertex. So if we're going to find the vertex here, what we're going to do is plug in our axis of symmetry for all the x values. It looks like in order for everything to work out, the graph would have to be downwards like this. That's how we would connect the dots here. But let's see what happens when we go to figure out our vertex, right? So I'm going to plug in 2.5 or 5/2 for all of the x values. Just be careful when you type it into your calculator. Y would equal negative 2 times 5/2 minus 1 times 2 times 5/2 minus 9. It's kind of annoying to use fractions. If you want to use decimals, that's fine. So this would be 2 times 5/2 is 5. 5 minus 1 is 4. 2 times 5/2 is 5. Minus 9 is negative 4. Looks like the y value would be 16. So your vertex would be 5/2 or 2.5 comma 16, which makes sense, right? If your axis of symmetry was 2.5, 16 is way up here. That point is your vertex, 2.5 comma 16. All right, that's great. So now let's go ahead and answer some of the other questions that we just got done talking about. One of those questions was, where is f of x greater than 0? Okay, this is asking you where are the y values greater than 0, and that happens above the x-axis. So right here. Those values are between 0.5 and 9/2, right? That's where the graph is above the x-axis. So we're going to say that this happens between 0.5 and 9/2. If I asked you where is the graph less than 0, that means where is the graph below the x-axis? Well, that would be over here. And it looks like that happens for when the graph is less than 0.5 and when it's greater than 9/2. That's where the graph is below the x-axis. So let's go ahead and write that. So before 1/2, we would say negative infinity to 1/2. And also we would say from 9/2 to infinity. We also talked about where the graph is increasing. And we know that increasing means if we trace the graph from left to right, it would be going up. So it's going up from negative infinity up until our point of inflection, which would be the vertex here. Okay. The graph is decreasing after our point of inflection to negative infinity, right? So it would be decreasing from 2.5 all the way for the rest of the right side of the graph. So the way that we're going to write that is we'll say the graph is increasing from negative infinity up to the x value of 2.5. It's always going to be where your axis of symmetry is. That's going to separate the increasing and decreasing for quadratics. The graph is decreasing from 2.5 to infinity. The graph is not constant anywhere. The last example that we do, I'll show you an example where we would have constant, but this is nowhere. And then finally, our point of inflection. Would be where the graph changes from increasing to decreasing. Of course, that would be your vertex. So we'll say 2.5, comma 16. Hopefully this is making a little bit more sense. Point of confusion is usually right over here where f of x is greater than 0. Increasing, sometimes people get a little confused by that. Remember, f of x is the same thing as y. So where is the y value above the x-axis? Right here. Increasing means where is the graph going up from left to right? Here. Okay, so I'd like to give you one more example. And what I'm going to do is I'm going to create a piecewise graph for you. And what that means is we are going to have different pieces of the graph. Okay, so if you can go ahead and add this to your notes. Let's go ahead, and this is what f of x will be. If you could just take a minute and draw a coordinate plane. Let's go 5 units in each direction. I'm going to put a point at -3, 1. I'm going to put a point at 0, -4. I'm going to put another point at 3, -4. And I'm going to connect the dots. So let's go ahead and do this. And we get a good looking graph that looks like that. And like I said before, this is what f of x will be defined as. All right, so with that done, let's go ahead and answer some of the questions that we had before. So even though we don't have an equation, we should still be able to answer some of those questions. For example, where is the y-intercept? Well, that's where the graph crosses the y-axis. It looks like that happens right here. The y-intercept would be -4. You could also say 0, -4. I could also ask you for the x-intercepts, which are the same thing as roots, which are the same thing as zeros. Those are synonyms in math. They all mean the same thing. It just means where does the graph cross the x-axis. Well, this one's right easy. It looks like it's going to cross right here at 4. Looks like it's close over here. Let's just call it -2. It's close enough. And it looks like we have one more. It looks like this point, this is -1, 2, 3, 4.5. Okay, so those are our x-intercepts, roots or zeros. I could ask you, where is the graph positive? Where is the graph negative? I could also ask you, where is the graph increasing, decreasing, constant, and any kind of inflection points. Remember, an inflection point is where the graph changes from increasing to decreasing or decreasing to increasing. So let's see if we can figure this out, and then that'll be it. Where is the graph above the x-axis? Well, it looks like, and remember we're only listing these are like domain values, right? So right here the graph is above the x-axis, and it looks like right here the graph is above the x-axis. So the question is, how are we going to write that? We're going to use our interval notation, and it looks like between -4.5 and -2 in union with 4 to infinity. Those would be where the graph is above the x-axis. Where is the graph below the x-axis? Well, of course, that would be the other section of the graph. Looks like we have this part over here. Don't forget about this piece. And then we also have all of this in the middle here. So let's go ahead and document that. So we're going to say, it looks like any x value before -4.5, so we would say from -infinity to -4.5. And then we also have the area between -2 and 4. Increasing, decreasing, constant, inflection, that's something totally different. Increasing means if you trace the graph, where is it going up from left to right? So I'm just going to start tracing. It looks like over here, if I trace the graph, it's going up, 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 right there. And then it starts coming down. And then if we just kind of keep tracing it, it's going down, 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 constant, constant, constant. It's going to start going up again right over here. Right, so that would be where the graph is increasing. So we could say this happens from -infinity to the x value of -3, and then also from an x value of 3 to infinity. Where is the graph decreasing? Well, that would mean the graph is going down from left to right. So let's figure out where that happens. It's going up, 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 down, 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 down. It looks like that's the only part where it's going down, right? Remember, we always go from left to right. So we're going to document that. This happens from -3 to 0. We're always listing the x values where that happens. Constant would be where the graph is flat from left to right. So of course, looks like the graph is flat from left to right right here. That would happen between 0 and 3. And then where is there an inflection point? Well, these wouldn't really count as inflection points because it's going from decreasing to constant, from constant to increasing. So those are not inflection points. An inflection point is where the graph is going from either decreasing to increasing or increasing to decreasing, which happens right here. Looks like the graph is going up. It's definitely increasing. And then at that point, that's where it starts decreasing again. Therefore, the inflection point, the point where it changes from increasing to decreasing or decreasing to increasing, would be the point -3, 1. Okay, so you guys have the classwork worksheet you could practice on, but then of course remember you have your reflection for today's class as well as your homework. Hope everyone has a good rest of your day, and I'll see you soon. Bye-bye.